Welcome back to another video on the Maths channel. It's your teacher, Mr. Lim here. And in this video, we're going to be looking at frequency distribution tables. So by the end of this lesson, you'll be able to read and write tallies, read and understand frequency distribution tables, and create them. So let's have a look at the first part of this lesson, reading and writing tallies. The number of Year 1 children wearing particular colored shirts on a Mufti day was recorded below. Write down the frequency of each color next to each tally. Now the word frequency just means how often it occurs. Okay, so here we've got pink, we've got 5 plus 5 plus 1, that's 11. Red, we've got 4. Grey, we've got 5 plus 5, that's 10. Green is 7. Blue is 12. Yellow is 9. And orange is 16. 5, 10, 15, 16. So each of these blocks, whenever there's a line through it, it represents 5. So 5 plus 5 plus 1 is 11. Okay, write the following numbers as tallies. I'm going to do question A with you, and then I want you to pause the video and have a go with B, C, and D. So 18, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, that's 15. So 16, 17, 18. Okay, pause the video, have a go at questions B, C, and D. Okay, questions B, 1, 2, 3. C, 1, 2, 3, 4, 5, 6, 7. And question D, 22, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and 1, 2. Okay, so that gives us 22. So you might be thinking, oh, what's the point of writing all these tallies? Can't we just write the number? Well, sometimes tallies can be useful. So let me go through one example of when tallies are useful. Let's say, for example, you're given this task of to count all the white cars in this parking lot. Okay, instead of counting 1, 2, 3, 4, 5, 6, 7, and then losing count, what you could do is you could just write a stroke for every time you see a white car. So you see a white car, another white car, another white car, another white car. You can just keep going. And then at the end, you can finally just count your tallies. Okay, and that makes it nice and easy. Or let's say, for example, you want to record the number of people wearing a green shirt that passes by a traffic intersection, okay, that crosses a road in 1 hour. Instead of counting every single time, just going up by 1, just write a tally. You don't even need to think about it. As soon as you see a person wearing a green shirt, just write a tally. Write a tally, write a tally, write a tally. And then after the hour has passed, you can just count that up. And that makes it nice and easy for you. Okay, so we've looked at how to read and understand tallies and also when they're useful. Let's have a look at how to read and understand frequency distribution tables. So here I've got a whole bunch of different examples. In our top row, we've got frequency of colors in a bag of Skittles. So we've got purple, yellow, red, green, blue, and orange. And we've got marks. Let's say it's a test score out of 10. So we can see here that in both of these examples, they have tally marks. Okay, not all frequency distributions have tallies, but like we have here in the second row, none of them have tallies. So I just wanted to show you both examples so you can get used to it. So the frequency is just the number that the tally represents. So there's 4 strokes here, so there's just 4. So what that means is there are 4 purple Skittles in that bag of Skittles. Or there are 7 yellow Skittles in that bag. Okay, or there are 5 blue ones. Or over here, we can see that 5 people got 7 out of 10 for the test. Or we can see that 4 people got 4 of 5 out of 10. Okay, now often we can see, often frequency distribution tables will have an extra row called total. Okay, and we just add up this, the tallies or the frequency. Okay, the tally and frequency total will be the same. So here we got 4 plus 7 plus 7 plus 6 plus 5 plus 4. Well, that's 10, 24, 29, 33. So this one's just going to be 33 here. So that means there are 33 Skittles in the packet. Or here we can say the total. 2, 4, 8, 10, 15, 19, 20. We can see that there are 20 people in this class, okay, who did the test. Here we've got siblings and frequency. Okay, how many siblings do you have? You could have no siblings. That's one person has no siblings. Or 4 people have 3 siblings, etc. We can also have a range. So the score or the outcome doesn't have to be a word. It doesn't have to be one particular number. It can be a range of numbers. So here we've got between 1 and 2 pets. 7 people have either 1 pet or 2 pets. Or we can say 3 people have either 5 pets or 6 pets. Okay, so what that could mean, it could mean that 3 people have 5 pets, or it could mean 3 people have 6 pets, or it could mean that one of them has 5 and 2 people have 6, or it could be 2 people have 5 and 1 has 6. Okay, and here's another example with the price range. We could say a really big online shoe store has a whole bunch of different shoes for different price ranges. They have 800 shoes available. That's between $0 and $50. The cheap pairs. They've got 1,200 pairs of shoes that are between 50 and 100. Okay, 700 pairs of shoes that are between 100 and 500, and then some really exclusive, expensive shoes, probably some Jordans or something like that. Alright, so let's have a look at some examples. The table below shows the survey results for the house team colors of a particular class of students. So we've got red, green, orange, and blue. How many students are in the green house? So we can see here, green, 2 students are in the green house. How many students are in the class? Well, we need a total. We need to work that out. So if we were to add all of these numbers together, we get 10, 15, 17. There are 17 people in the class. If a student was picked at random, what's the probability that they are in the orange house? Well, there's 7 people in the orange house out of 17. So the probability is just 7 out of 17. Okay. Question B, a basketball player's performance in one game is recorded in the following table. Complete the table above. How many shots went in and how many shots did the player miss? How about I get you to pause the video and have a go with this. Okay, so we can see that's 3, 5, 10, 13, 5, 7, and 2. So how many shots went in? 7 shots went in. How many shots did the player miss? Well, they took 13 shots at goal and 7 of them went in, so they must have missed 6. Okay, 13 minus 7 is 6. Okay. Let's move on to the last section of this lesson, creating frequency distribution tables. A die is rolled 10 times and outcomes are recorded in the table below. So I'm going to get my trusty dice over here. And we are going to roll it 10 times and we're going to see what the outcomes are. So we get a 3. a 6, another 6, a 2, another 6, a 1, a 4, another 6, another 6. Okay, and so we've done it 9 times now. We need to roll it one more time. And we finally got a 5. Okay, well, I was not expecting that. But we can see here that frequency is just 1, 1, 1, 1, 1, and 5. So a total of 10 because we rolled it 10 times. And that's it. Okay, so if there was a question that asks you, well, how many times was the die rolled? Did the die roll a 3? The answer is 1. If the question asks, oh, how many times was a 5 or more rolled? Well, 5 or more. Well, a 5 was rolled 1 time. A 6 was rolled 5 times. So the answer would be 6. 1 plus 5. If the question said, how many times was did the die roll at least a 3? At least a 3 means 3 or more. So we're going to add all of these numbers together, which is 8. Or if the question said at most a 4, that means 4 or less. We can't go more than 4. At most 4. That means we need to add all of these ones, which is 4. Okay. Question B. A coin is flipped 10 times and the results are recorded in the table below. So let's get our coin. We're going to flip this. Tails. Tails. Heads. Tails. Heads. 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 Okay, that's 8 times. This is our 9th time. Heads. And heads. Okay. So we've flipped the coin 10 times. We can see that there were 7 heads and there were 3 tails for a total of 10. Okay. A teacher asks her class how many people are in their family. The results are 4, 3, 4, 5, 3, 6, 3, 3, 4, 4, 4, 3, 5, 8, 3, 2. Construct a frequency distribution table. Can I get you to pause the video and have a go with this one yourselves? Okay, so the first thing I would do is I would just count how many different scores there are or what the smallest one is. The smallest one is 2, and then the largest one is 8. So I might say 2, 3, 4, 5, 6, 7, and 8. Let's do that. So how many 2s are there? There's only 1. How many 3s? 1, 2, 3, 4, 5, and 6. How many 4s? 1, 2, 3, 4, and 5. How many 5s are there? 1, 2. How many 6s? There's 1 6. There's no 7s. And then there's 1 8. Okay, you don't need to do the tally. You can if you want to, but I'm not too fussed. And it'll be good to write a total as well, because that will help. Total, we've got 7, 12, 14, 15, 16. Okay, and we can just double check, right? We can count how many numbers there were. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Good. We didn't miss any. Alright, I want you to pause the video and answer the next 4 questions. Use the frequency distribution table that you've created to answer them. Okay, part 2. How many students have 4 people in the family? Well, 4 people in the family, 5 students have them. 5 students have 4 people in their family. What is the most common number of people in the family? Most common number of people? Well, 6 is the most common. And that's saying that the most common number of people in the family is 3. How many students have at least 4 people in the family? So at least 4 people in the family means 4 or more people in the family. So that means we need to add all of these numbers here. 5 plus 2 plus 1 plus 0 plus 1. That's 8, 9. 9 students have at least 4 people in their family. And question 5, how many students have at most 5 people in the family? So that means no more than 5, or 5 or less. So they can have 5, they can have 4, 3, or 2 people in the family. So that means we need to count these numbers. 2 plus 5 plus 6 plus 1, that's 7 plus 7, that's 14. Okay, and that's it for this video.